So you've found a mineral that you're interested in and you'd like to identify it. Now these set of procedures are going to go over the EDS measurement procedures. Okay, so let's pretend we've been navigating around and we found this mineral here. Okay, it's no accident that I found this mineral. This is actually a standard, and it's the benitoite standard on SPI2. It's a barium titanium silicate mineral, and it fluoresces when under the beam, that when it interacts with an electron beam. So if you found, let's pretend this is an unknown. What you want to do is have your image in focus, and also what's really vital is have your OMTV in focus as well. Now in this case it's in focus. Let's put it out of focus just to show you. This is what it looks like out of focus, and then we'll put it in focus. So the reason why I chose benitoite, because of this fluorescence phenomenon, I can actually show you where the beam is located. Okay, so if we turn the scan generator off, you'll see this fluorescent circle on the surface of the sample. This right here is the location of the beam. Now this can be helpful in some ways. This is exactly where the beam is striking the sample. So if you're running this remotely, you can have your laptop with the main probe screen over here, and then have a projector project the live video feed onto a whiteboard, right? And then if you're on the benitoite standard, you can then trace the location of the beam, and then as you switch to your SEI image on the whiteboard, you'll have the location of the beam, so you'll know where the beam is in relation to where you are on the electronic image. Okay, but the important reason why I wanted to show you the location of the beam is that when you're out of focus, when you move the focus up and down, you're moving the stage up and down in the Z direction. Okay, and when you're out of focus, you're out of alignment with the optical axis. So if I'm out of focus, this is what the beam looks like. It basically is not converging on one focal point. So you're not going to have a good analysis if you're out of focus. This is why it's so important to optically focus the stage so that you know where the beam is and you know what you're analyzing. So oops, just a little bit off. Okay, right there. So there we have a nice, everything is optically in focus. We've lowered or raised the stage to the perfect spot where the beam converges onto your sample. Perfect. Okay, so let's put the PCD in. Now, EDS stands for Energy Dispersive X-ray Spectrometry, and we use this for a quick and dirty non-quantitative examination. Basically mineral identification. We'll find out what elements are in this mineral, and then we can identify it. I know this has been benitoite. I just use it to show the location of the beam, but we'll pretend we don't know. Okay, so open up the EDS window by pressing EDS here on the offline menu and click on EDS. This is the only option in the drop down menu that you need to use. Sometimes if the EDS the program is opened by another user or on locally and they didn't close it, the EDS home window won't show up. Okay, if that's the case, then hit EDS end. Please, please, please don't ever hit EDS calibration, EDS analyzer, or EDS reset. Just causes software problems, so we just want you to focus on these two. Okay. So here's our EDS home window. This is basically graphic interface that plots energy versus wavelengths for the generated X-rays. Okay. And it collects the X-rays, all X-rays simultaneously, which is great, easy, and quick. Right now we have it preset to 10 seconds. That's fine. We can change that and add, maybe do 20 seconds if you'd like to resolve some peaks or get a better collection. Okay, so all you hit, oh, we turn the scan generator off, it's off. Okay, and then we hit acquire. So right now it's collecting the x-rays coming off the sample. It'll run for a few seconds. Okay, great. Now, and you can adjust the scale to your energy plot by hitting auto. Okay, and you know, great. So what? We've got a bunch of x-ray peaks. What does this really tell us? All right, so if you go to operation, go to the periodic table, and this opens up a second window, and here it shows you the periodic table, and you can click on any element and it'll show you where its respective energy lines and peaks would be. So silica, that's there, that's good. Titanium, that's also there, and finally barium, which is associated with all those peaks, which we do see. You can manually adjust the scale by pressing this up and down button, so we can get a better look at the barium peaks, which it's there. Now there's kind of an issue with barium, titanium. They do have a lot of peak overlap. If you see, those are the titanium peaks and those are the barium peaks. So those first two barium and titanium peaks are very close together, and that could be a problem if we're quantifying using the EDS, but we're not. We're just identifying this mineral. So and you also, the peaks, the lower energy peaks like carbon, that's there obviously because we carbon coded the standard, and then oxygen will be there as well. That's an oxygen peak. Okay, so that's pretty much the introduction on how to use the EDS. So if you want to use it again, you can just say close the periodic table right there, open up the PCD, turn on the scan generator, go back to video 1, and move on to the next mineral. And say we move, let's go over here. Now again, this is still just benitoite, but let's just pretend it's a different sample. Okay, we've moved over here, that's great. Let's go make sure our OMTV is in focus. It's not. We barely moved anywhere, but it just got out of focus. Okay. And you also kind of want to avoid cracks and bad spots, so you can move over to maybe a spot that's little, like right there. Okay, then close your PCD, turn your scan off, and hit acquire again. And you can do this over and over again, identify all the minerals on your thin section, and then decide which ones you'd like to analyze with the WDS.